Again, you should be relatively familiar with this, but in case you're not, need a little refresher. We find the median by arranging the original data set in increasing or decreasing, doesn't matter as long as they're arranged highest to low or lowest to high. And we take the middle number where we average if needed. So if there are 7 values in the data set, we order them high to low. You just get to take the middle one. We don't have to average, but if you take a data set of 8 values, then we do have to average those middle 2 because there's not an exact middle. The biggest thing about a median, just don't forget that whenever you see the data set, you have to arrange from increasing in increasing or decreasing order. Okay, you can't just take the data set as listed. Just go ahead and make sure you arrange it. That's the biggest thing. As long as you do that, you know how to find a median. You've done it many times in your life. Some properties. It is possibly a value in the data set. Again, that's not necessarily a good or bad thing. It's just a thing. Just an FYI. It's possibly in the data set. If you have an odd number of data values in your data set, it is in the data set. We know that. If you have an even number, it might be, depending on if the 2 middle numbers are the same. Again, just is what it is. It's not good or bad. It's just reminding you that, hey, a mean won't be in the data set, no big deal. Median possibly could be, just FYI. The median is very robust or resistant. And this is where I want to come back to that previous, 2 slides ago where we said the mean is not robust and resistant, but it's the most commonly used. And you say, wait a minute. That was confusing. This is even more confusing. If the median is robust and resistant, and we want to avoid outliers, why aren't we using it more? And that would be a great question. The answer is that medians don't have good mathematical properties. I'm not going to test you on that. It's just an FYI just to help explain the chaos of this. Means have good mathematical properties, but they're not robust and resistant. And so when we get later on in this course, we're going to talk about how we're using a mean, but the fact that outliers could throw us off is going to cause a problem. And how do we deal with that? And in the back of your mind, you might be saying, well, if we just used a median, we wouldn't have to worry about that. And you'd be right. The problem is the math that we have to do for a median gets really complicated really fast and it gets really hairy. So we tend to not use medians in courses like this. We tend to use medians in potentially an upper level course, but mainly in not until grad school level statistics do we use medians because how complicated they get. And the last property, as with a mean, it cannot be used with qualitative data, as we talked about. You could not find the median, you could find the mean zip code, just like you could find the median zip code. Both of them wouldn't have any meaning, right? If you averaged 5 zip codes, you would get a number. It wouldn't mean anything. If you took the median of 5 zip codes, you could get a number. It wouldn't mean anything. That's why we don't use it for that type of data. If it's colors, it's even more of a problem, right? How do you arrange colors, right? You could do it alphabetically, you could do it by rainbow order. There's no real set way to do it. So we stay away from medians and means with qualitative data. And then the last measure of center we're going to talk about, again, the other one that you are aware of is a mode. Again, you found mean, medians, and modes your entire life. The mode is the data value that occurs with the greatest frequency. Some properties of a mode: a data set can be unimodal, bimodal, multimodal, or have no mode. Right? A data set can just have one mode, that'd be unimodal. It could be bimodal, could have 2 modes. Multimodal could have 3 or more modes. Or it could have no mode. If a data set does not have a single value that repeats, that would be, that data set would have no mode. If the mode exists, as in it's unimodal, bimodal, or multimodal, it has to be in the data set. Well, that makes sense. The mode is the data value that occurs with the greatest frequency. So if it does exist, then it has to be in the data set because it happened the most in the data set. Again, not a good thing or a bad thing, just is what it is. If you have a mode, it has to be in the data set, as opposed to, again, a mean, which does not have to be. It's highly variable from data set to data set, and that's why we don't use it with quantitative data, because modes can just vary wildly from data set to data set, and that creates a little bit of concern. We'd like to use statistics that if I were to take a data set and calculate a statistic on the data set, and we're going to a similar but different data set and calculate a statistic, I'd get probably, hopefully, a similar, maybe a little bit off, but similar number. A mode can vary wildly, and that problem is something that a reason that we stay away from using modes with quantitative data. However, because it can be used with qualitative data, and the other two we talked about can't, this is where we use a mode. Because with qualitative data, again, like colors, you could easily use a mode because you would say, well, I have a package of M&Ms and which color occurs with the greatest frequency. And so that's where modes typically come in, is with qualitative data. Next, we are going to talk about distribution shapes. So as an FYI, as we move forward in this course, we're going to talk about three things with regards to data sets. We're going to talk about center, we're going to talk about shape, and we're going to talk about spread. And those are the three that you see as our main sections here. We've talked about center just now. Skewness and shape are related concepts we're going to talk about next, and then we're going to talk about spread after that. So when we talk about the shape of a distribution, we have three options. We have a data set that can be right skewed, which means that it has a long right tail. This data set has a mode less than its median, less than its mean. What that means, if I were to draw a picture for you from left to right, that means because I have a long right tail, the peak of that curve is going to be the mode. And why is that? Because if I'm talking about a curve, I'm talking about think about like a bar graph, right? It's not that, but think about it like a bar graph and say the bar that's the highest is the highest frequency, right? So when I draw that curve for you of what the shape of the distribution looks like, when I draw that curve, its peak has the most frequency. Well, that's the mode, right? We just covered that. And then because it has a right tail that goes along out, remember we said that the median is robust, which means those outliers don't affect it. The mean is affected by it. So that should make sense to you, because that long right tail, where there's not a lot of observations, but they're happening way out the tail, those would be outliers. And those outliers are going to pull that mean further out. Okay, so if you visually were to draw it, it would say that we have a sharp peak, and then it tails off to the right, and then in order you would have the mode, and then the median, and then the mean. The left skew distribution is going to be the opposite of that, which has a longer left tail. So it's going to be one that, again, if I'm drawing out a picture going from left to right, is we start off really low for a long while, and then we peak really sharply and then fall quickly. So it's just going to mirror what we just talked about, and that's going to be where the mean is the first thing, because it's pulled out by those outliers. Then the median, then the mode, again, is going to get the peak. And then the last option for a distribution is symmetric, and that's one where we have a similar tail on both sides. And a symmetric distribution has the same value for the median and the mean, and if it's unimodal, the mode will be there as well.